Hey guys, I am Venkat, and in this short 3-part video series, we'll discuss all the basics you need to get started with MongoDB, a cross-platform non-relational database. First, let's understand the difference between a relational and a non-relational database. In a relational database like SQL Server or Oracle, a database is a collection of tables. That is, it contains one or more tables, and it is these tables that store data. Simply put, a relational database is a collection of one or more tables. A database table contains one or more rows, that is, it's a collection of rows. A table row contains one or more columns. In a non-relational database like MongoDB, for example, we do not have tables. Instead, we have collections and documents. A collection, as the name implies, is a collection of one or more documents. If you're from a relational database background, you can think of a collection as a table and documents as table rows. So in MongoDB, a database contains one or more collections. A collection is made up of one or more documents, and each document is made up of one or more fields. Now, both in SQL, that is relational, and non-relational world, we have database at the top. In SQL, we have tables, and in the non-relational world, like MongoDB, for example, we have collections. Table rows in SQL world correspond to BSON documents in MongoDB. BSON is binary JSON. We'll discuss JSON and BSON and the difference between them in just a bit. A column in the SQL world corresponds to a field in a JSON document. Now, it gets a bit easier if we understand these 4 technical terms in MongoDB: collection, document, JSON, and BSON. So, in a nutshell, think of a collection as a table and a document as a table row. Now, let's switch gears a bit and understand JSON and BSON. At the end of the day, MongoDB is a database, and we use it to store data. In a relational database like SQL Server, data is stored in a table, obviously in rows and columns. In MongoDB, we do not have tables. Instead, we have documents. So data in MongoDB is stored in BSON documents. BSON is binary JSON. So first, let's understand what is JSON. The acronym JSON stands for JavaScript Object Notation. In this example, we have student data. JSON format is text-based, and both humans and machines can very easily read it. This is the reason it became a very popular format for storing and exchanging data between software systems. Data in a JSON document is stored in key value pairs. Example, name: John. A key value pair consists of a field name in double quotes followed by a colon followed by a value. Value can be a string, number, boolean, or an array. In this example, name field value is a string, age is a number, graduated is a boolean value, true or false, awards is an array. A field value in a JSON document can also be another nested JSON document. In this example, address field value is another JSON document with its own set of fields and values. So the address is an embedded JSON document. There is a one-to-one relationship between student and address. To model something like this, in a relational database, we may have 2 tables. Students stores students data. Addresses store address data. To retrieve data, we have to join and query both the tables. In Mongo, we have the entire data in one document. There is obviously no need for expensive join operations. Awards field value is an array. A student may have received 0 or more awards. So there's a one-to-many relationship between students and awards. Again, to model something like this in a relational database, we may have 2 database tables. Students stores students data. Awards stores awards data. In Mongo, we have all the data in one JSON document. Now, what's the difference between JSON and BSON? JSON stands for JavaScript Object Notation, and BSON stands for Binary JavaScript Object Notation. Simply put, BSON is binary JSON, and it is in this format MongoDB stores data internally on the disk. So, in a nutshell, BSON is the serialization format used in MongoDB. At this point, you might be wondering, we already have JSON. Why did MongoDB invent BSON? Well, JSON only supports a limited number of basic data types: string, boolean, number, array. Also, JSON is a text-based format, and parsing JSON text is very slow. We want database engines to be fast. We don't want text parsing to slow it down. Hence, MongoDB invented BSON. The following are the three primary differences between JSON and BSON. At this point, you might be wondering, should I now learn this new binary BSON format? Well, no. As developers, we still use JSON format, and MongoDB takes care of converting it to BSON and saving it on the disk. In your JSON documents, if required, use the additional data types provided by BSON. We don't have to worry about the internal BSON format. It's all taken care of by MongoDB. Remember, BSON is a binary representation of JSON, and it contains more data types than JSON. So you can think of BSON as a superset of JSON. Now, let's take a look at a very simple but a real-world use case. Let's say we are developing an application for a training institute, and we have a page that displays student names and the courses they have enrolled in on a web page, as you can see right here. To model something like this, in a relational database world like SQL Server or Oracle, we typically create three tables. Students stores the details of students like ID and name. Courses stores the course details like course ID and name. Student courses, there is a many-to-many relationship between students and course tables, meaning a student can enroll in multiple, that is, many courses. Similarly, a given course can have multiple students enrolled. So this is the table that links students and courses, basically the bridge table for many-to-many relationship between students and courses. On the application side, to be able to display this database data, we may have a class that looks like the following. This is a very simple example here. In the real world, in our application layer, we may use object-oriented programming concepts like inheritance, polymorphism, etc. between classes, which makes it even more difficult and a painful exercise to map our application layer objects to database tables and rows. So the point that I'm trying to get across is there is a lot of misalignment between application classes and database tables. Simply put, our application objects are not tables and rows. Now, to fill this gap and misalignment, we may write a custom mapping layer or use ORMs, that is, object relational mappers, like Entity Framework, for example. As software engineers, we want to reduce all this complexity and use of additional softwares. Instead, we want a database that is easy to use with our application code. Now, let's see how this same data may be stored in a non-relational database like MongoDB. As we have already discussed, in Mongo, we do not have tables and rows. Instead, we have collections and documents. You can think of a collection in MongoDB as a table in a relational database and a document as a table row. In this example, we have one collection. The name of the collection is student courses. In this collection, we have three documents. So just like how a table is a container for rows, a collection is a container for documents. It is the document that physically stores data. The data is in BSON format, so the documents are also called BSON documents. If you're wondering what is BSON, well, it's binary JSON. MongoDB stores data on the disk in BSON format. The same students and courses data that we have across three tables in a relational database can be stored in a single collection in Mongo as shown right here. For any application, this data is very easy to work with. No complex joins and mapping layers are required. Our application code will be much cleaner, simpler, and easier to maintain. So, does this mean we cannot define relationships between documents in a non-relational database like MongoDB? Well, we can define relationships between documents in MongoDB, but these are usually capped to an absolute minimum. In most cases, we embed JSON documents inside another document. The obvious benefit of this approach is we have all the data we need in one place, and there is no need to traverse multiple related documents. Here's the important bit. We can define relationships or references in MongoDB. We can even completely normalize schema in MongoDB just like a relational database. But the question is, if you want to normalize and use a non-relational database like a relational database, why use a non-relational database? Use a relational database like SQL Server or Oracle. This nicely leads us to another common question we may have: when to use a relational database like SQL Server over a non-relational database like MongoDB and vice versa. Well, relational databases are still the best choice if the data is predictable in terms of structure, size, and frequency of access. Also, if relationships between entities are important, again, relational databases are the best choice. Normalization in a relational database reduces the size of the data on disk by limiting duplicate data and anomalies. In a non-relational database, documents are embedded within documents, which helps keep data that will be accessed together in the same place. But if this isn't right for your needs, use a relational database. For example, if you have a very large data set with complex structure and relationships, embedding might not create clear enough relationships. Finally, relational databases have been around for a very, very long time, which means there is wide support available from tools to integration with data from other systems. On the other hand, if you want a flexible schema for the data, that is in terms of shape or size, or if it needs to be open to change in the future, then a non-relational database is the answer. Non-relational databases have been designed from the ground up for the cloud, which makes them naturally good for horizontal scaling, where lots of small servers can be spun up to handle increased load. Now, what is NoSQL? Lots of people use these two terms, NoSQL database and non-relational database, interchangeably. A non-relational database like MongoDB is more than a NoSQL database. So, what does NoSQL stand for? Well, when we hear this term, we think NoSQL means there is no SQL. This is not true. The term NoSQL stands for not only SQL, and it means a non-relational database is a non-tabular database and stores data differently than relational tables. For example, in a relational database like SQL Server or Oracle, data is stored in tables, whereas in a non-relational database like MongoDB, data is stored in JSON documents. There are different types of non-relational databases. Document database. As the name implies, data is stored in documents. For example, in JSON documents. Examples of document databases are MongoDB and CouchDB. Key value database. It stores data as a collection of key value pairs in which a key is used as a unique identifier. Both keys and values can be anything ranging from simple objects to complex compound objects. Examples are DynamoDB and Redis. Wide column store. It's similar to a relational database in the sense it stores data in rows and columns. However, the columns are dynamic and each row does not have to have same columns. Examples are HBase and Cassandra. Finally, graph database. It is used to store and navigate relationships. There's no limit to the kind and number of relationships. It's heavily used in fraud detection and social networking. It is easy to create relationships between data entities and quickly query these relationships. For example, you can find out who the friends of a particular person are. Examples: dgraph and OrientDB. Now, let's focus on the benefits of using a document database. It has easy to use data model. In a document database like MongoDB, we do not have tables and rows. Instead, we have collections and documents. The data that we typically store across many relational database tables can be stored in a single collection. For an application, this data is very easy to work with. No complex joins and mapping layers are required. Our application code will be much cleaner, simpler, and easier to maintain. Flexible schema is another benefit. JSON documents that actually store data have a flexible schema, which means it's perfectly okay and normal for two documents to have different fields. In this example, we have two documents with student data. Both the documents have ID and name fields. In the first document, we have graduated Boolean field, whereas in the second document, instead of graduated, we have a string gender field. So the point is, document schema in Mongo is dynamic and self-describing. Every document we save in Mongo can be as flat and simple or as complex as our application requires. MongoDB query language MQL is based on JavaScript and very easy to learn. When querying data, you have a wide range of options, operators, expressions, and filters. Data is very easy to query and you rarely need joins or transactions. The MongoDB query language is a full-featured, powerful language that allows you to query deep into documents and even use the aggregation framework to perform complex analytics with just a few lines. Indexing is also supported, which means documents can be retrieved quickly. Most relational or SQL databases allow only vertical scaling, which is also commonly called scaling up. Vertical scaling involves adding more resources like memory, storage, etc. to the existing database server. Vertical scaling has an upper limit beyond which you cannot just add more CPU, memory, etc. There is also downtime involved. You have to shut the database server down to add more hardware. MongoDB, on the other hand, supports horizontal scaling, which is also commonly called scaling out. In horizontal scaling, data is partitioned and distributed across many servers. So, in simple terms, scaling horizontally means adding more servers to the already existing pool of servers. This means you're not limited to the capacity of a single server. There is no need to turn off existing servers to add a new server to the pool. So there's no downtime as well. So non-relational databases like MongoDB have become very popular. The following is one of the common questions asked these days in a software engineer interview. Have you got any experience with a non-relational database? What's the difference between a relational and a non-relational database? Non-relational databases are gaining great traction and they're here to stay. If you're a software engineer, it's invaluable to have a non-relational database like MongoDB in your tool belt. Hey guys, this is part 2 of MongoDB video series. In this video, we'll discuss how to get started with MongoDB database. Our first 10 viewers to use this code on MongoDB Atlas will get $100 of credits. MongoDB is a multi-cloud document database service. In short, it's a document-oriented database. To easily get started with MongoDB, use MongoDB Atlas, which is a fully managed cloud database on AWS, Azure, or GCP, Google Cloud Platform. In a web browser, navigate to this URL, mongodb.com, and then click on this Try Free button. Provide your email address, password, and then follow the on-screen instructions to create a free account. You can also use your Google account to register. In my case, I already have an account created, so let me click on this Sign In button. Provide login email address, and then click Next. Provide the password, and then click Login. Our next step is to create a database, and for that, click on this button, Build a Database. Use this free shared option to learn and explore MongoDB in a cloud environment. So let me click this Create button. With this free option, we get 512 MB of storage space, and then we can choose our preferred cloud service provider, AWS, Google Cloud, or Azure. I'm going to select Azure, and then we select where we want our Mongo database instance to be hosted. I'm going to select East US, and then finally click Create Cluster. 5 simple steps to get started with Mongo Cluster in the cloud. First, create the cluster itself in the cloud. Create database user, which we can use to access the Mongo database. Add IP address of your computer or device from which you want to connect to Mongo database. If you already have sample data set, load it into Mongo database. Otherwise, you can manually create. Finally, connect to your Mongo cluster. How would you like to authenticate your connection? Well, we're going to use username and password. So I select that, provide an username and password, and then click create user. Next, where would you like to connect from? Well, in our case, we want to be able to connect from our local environment. So select my local environment, and then we need to provide the IP address of the device or computer that we're going to use to connect to MongoDB. We can either manually enter the IP address of our device, or when I click this add my current IP address, it's going to use automatically the IP address of my machine from which I am accessing MongoDB at the moment. Finally, click finish and close. There we go. Congratulations on setting up access rules. Let's go to the databases. So click this button. At the moment, as you can see, we are on the databases menu and we can see our cluster created. Remember, with the free shared option, we get 512 MB of storage space, and we can see that right here. And at the moment, the data size is 0 bytes. And that makes sense because we don't have any data in the database. Now let's connect to this database. And for that, click the connect button. There are 3 ways we can connect to MongoDB Atlas: MongoDB Shell, MongoDB Compass, and your custom application. MongoDB Shell is an interactive JavaScript interface for querying and modifying database data. We can also use it to perform administrative operations like creating databases, collections, etc. MongoDB Compass, on the other hand, is a GUI, graphical user interface, for querying, visualizing, and modifying database data. Behind the scenes, both the shell and Compass issues the same commands to the database server. You can also connect your own custom application. This application may be built using any technology: .NET, Java, PHP, Node, Python, etc. It doesn't matter. We have the 3 options here to connect to MongoDB. First, let's connect using MongoDB Shell. You can download the MongoDB Shell for your operating system from this page. Select your operating system from this drop-down list, download MongoDB Shell and install it. And here is the connection string to connect to MongoDB. So let me copy this and then fire up command prompt. In the command prompt, paste the connection string and then press the enter key. Enter the password and then press the enter key again. There we go, we are connected. And notice the name of the database here, my first database. We did not create this database yet, but why is MongoDB showing that we are connected to my first database? Well, that's because in the connection string, we specified my first database as the name of the database that we want to connect to. Though this database does not exist yet, MongoDB allows us to connect to it. And this database will be automatically created when we create our first collection. We'll see that in action in just a bit. And at the moment, to see the list of databases that we have, use this command, show DBs. At the moment, we only have these 2 databases, admin and local. We don't have this my first database created yet. It'll be automatically created when we create our first collection. And to create a collection, we use this command, db.createCollection. And then we specify a name for our collection. Let's call it users collection. Remember, a collection in MongoDB is similar to a table in a relational database. Hit enter. There we go. At this point, we should have both the database and the collection created. So if we execute this command again, show DBs, we see all the 3 databases, including my first database. And at the moment, my first database is in use, meaning any commands that we execute will be executed against my first database. How do I know that? Well, that is what is displayed in the prompt right here. So if we want to see all the collections that we have in this my first database, we use this command, show collections. There we go. We see the users collection that we have just created. At the moment, my first database is in use. How do we know? Well, that's what is the name displayed in the prompt right here. What if we want to switch to another database? For example, let's switch to admin database. For that, we use this command, use the name of the database that we want to switch to. In our case, we want to switch to admin database. Notice admin is displayed in the prompt right here, letting us know that the admin database is in use. Now let's switch back to my first database. Now, to clear the screen, use the command cls. Let's create another collection. Remember the command to create a collection? db.createCollection. And to this method, we specify the name of the collection. Let's call this test collection. To see the list of all collections that we have in the current database, we use this command, show collections. As expected, we have two collections. Let's drop one of these collections. And the command to drop a collection is db dot name of the collection that we want to drop. Let's drop test collection. And then we use the drop method. Show collections. We see the only users collection. One way to tell the database in use is by looking at the prompt. We also have a command for that, db. This command displays the database in use. As you can see, my first database is in use at the moment. Remember, a collection in MongoDB is made up of one or more JSON documents. So let's perform CRUD operations against a collection. That is, create, read, update, and delete JSON documents from a collection. And here's the command for that, db dot the name of the collection. In this example, the name of the collection is student courses dot insert one. This method inserts one JSON document. Since we are inserting a JSON document, we have a pair of curly braces and then key value pairs. So the key here is name, value is Mike. Similarly, we have age 30, gender male, graduated false, address is another embedded JSON document. So we have another pair of curly braces with its own set of key value fields. And then courses. Courses is an array, so that's why we have a pair of square brackets. So let me copy this. We are back in Mongo shell. Before we paste and execute the command that we have just copied, let's see the list of collections that we have. Remember the command, show collections. At the moment, in my first database, we have only one collection, users collection. Now let me paste the command that we have just copied. There we go, command completed. If we now execute show collections, we see both the collections. Now, to find all the documents in a collection, we use this command, db dot name of the collection. In our case, the name of the collection is student courses dot find. There we go. We see the one document that we just inserted. This ID field is a special field. We'll discuss more about it in just a bit. Now, to insert one document into a MongoDB collection, we use insert one method. But what if I want to insert more than one document at a time into the collection? Well, we can use the aptly named insert many method. And here's the syntax for that. Same idea, db dot the name of the collection. In our case, the name of the collection is student courses dot insert many. To this method, we are passing an array of JSON documents. So we have a pair of square brackets. So here is the opening square bracket and here is the closing square bracket. And then we pass an array of JSON documents. So here is our first JSON document with a pair of curly braces, and we have a comma, and then the second JSON document, another comma, and then our final third JSON document. We are closing the square bracket and then the closing parenthesis of insert many method, finally a semicolon. Let's press the enter key. There we go, query completed. Let's retrieve all the documents using this command, db.studentcourses.find. There we go, we have all the 4 JSON documents. Find method has 2 parameters, query and projection. Both are optional parameters. We use the query parameter to filter data. So you can think of it like a where clause in SQL. If we do not include the query parameter or pass an empty document, that is just a pair of curly braces like this, find method returns all the documents. If you want to filter the documents that are returned, then use the query parameter. And here is the syntax for that. For example, let's say we want to find all documents where name is Ben. So db dot the name of the collection student courses dot find. We want to find all those students whose name is Ben. So in a pair of curly braces, name colon Ben. Now let's write another example. Find all documents where age is 28. So again, db.studentcourses.find age colon 28. Now find all documents where age is less than or equal to 30. So as usual, we use the find method. The field is age, and then we want to use less than or equal to operator. So LTE stands for less than or equal to, and all query operators in MongoDB starts with dollar. So we have dollar symbol there, and the value is 30. So when we execute this query, notice we get all the students whose age is less than or equal to 30. The following is the syntax to use a query operator in a pair of curly braces field name. In our case, the field name is age, colon, and then another pair of curly braces. Remember, query operators in Mongo start with dollar sign. So dollar and then the name of the operator. The following are some of the common comparison query operators. EQ stands for equal to, NE for not equals, etc. In our case, we want to use less than or equal to operator. So LTE colon the value for the field. In our case, the field is age. It's a number. So we specified a value of 30. So this is going to return all documents where age is less than or equal to 30. Another example. Let's say we want to find all documents where age field value matches any of the values specified in this array. So as usual, the field name is age. The operator that we want to use is in, and then the array of values. So if we execute this, we get all documents where age is in 28, 29, and 30. Now, the second parameter of the find method is projection. By default, queries in MongoDB return all fields in matching documents. To limit the amount of data that MongoDB returns, you can include a projection. A projection basically tells what fields to include or exclude in the matching documents. Use 1 to include a field and 0 to exclude a field. Let's take a look at an example. Now, db dot the name of the collection dot find without any parameters returns all the documents. Similarly, if we pass an empty object to the find method, again, it also returns all the documents. Now let's say we want to find all those students whose age is less than or equal to 30. So the field name is age. We want to use less than or equal to query operator. Query operators start with dollar. So in another pair of curly braces, we use dollar less than or equal to query operator colon the value is 30. So when we execute this, we get all the students whose age is less than or equal to 30. And here's the important bit. Notice in the result set, we have all the fields, ID, name, age, gender, etc. Now, we don't want all the fields. Let's say we only want to include name and age fields in the result set. For that, we include the second parameter. Remember, the second parameter is the projection parameter. So we include a comma and then another pair of curly braces, and here we specify the fields that we want to include. In our case, we want to include the name field, so name colon 1. We also want to include age field, so age colon 1. Notice in the result set, along with name and age fields, we also have the ID field. ID field is always returned. If you don't want it to be returned, then you have to explicitly specify. So we don't want the ID field underscore ID colon 0. When we execute this, notice we only get the name and age fields. Now, consider this example. Basically, with the second projection parameter, we are saying in the output, we want name and age fields, but not the ID field. Now, let's see what's going to happen if we also include gender field in the exclusion list. Basically, we're saying in the output, we want name and age fields, but not ID and gender. Notice we have an error. Cannot do exclusion on field gender in inclusion projection. So the point is you cannot specify the fields that you want to include and exclude at the same time in a projection. You can only specify an inclusion projection or exclusion projection. Underscore ID field is the only exception. For example, let's say in the result set, we want all the fields except the gender field. For that, we use exclusion projection, meaning in the second parameter, that is the projection parameter, we specify the fields that we want to exclude. In our case, we don't want gender, so we specify gender colon 0. This means all the fields will be returned except gender. So this projection here is an exclusion projection. Take a look at the address field. The value for this field is another nested JSON document. What if we want to find all documents where city is star city? We can simply use dot notation for this. For example, address.city equals whatever is the city. So db.collection name, by the way, if you type part of the collection name and then press the tab key, it auto-completes. Dot find a pair of curly braces and then the field name address dot city colon the value. In our case, the value is star city. Notice we have a syntax error, and that's because we are missing quotes around the field name. Address.city must be inside double quotes. There we go. We have the result as expected. Find method has two input parameters, query and projection. Both are optional parameters, and the return type is a cursor. You can think of the cursor as a virtual object that stores the documents returned by the find method. So this means along with the find method, we can also use methods like count, sort, skip, limit, etc. These three methods, sort, skip, and limit, are particularly useful to implement server-side sorting and paging. One way to find the total count of documents in a given collection is by using find and count methods together. So db.collectionname.find.count. There we go. Total 4 documents. Can we find all documents where gender is female? Well, we can. We simply use the query parameter of the find method. So we want to find all documents where gender is female. There we go. We have 2 such documents. To sort data, we use sort method. We want to be able to sort by age field, so we specify the field name as age, and to sort in ascending order, use 1. To sort in descending order, -1. Notice the documents are sorted by the age field in descending order. Now let's skip the first document and then take the next 2 documents. For that, let's use skip and limit methods. So on the sort method, let's append skip method. We want to skip the first 1 document, so 1 is the parameter, and we want to take the next 2 documents. So to the limit method, let's pass 2. There we go. We have the output as expected. Now, to insert one document into a MongoDB collection, we use insert one method. To insert more than one document, we use insert many. Along the same lines, to update a single document, we use update one. And to update more than one document, we use update many. First, let's find all the documents. We want to change the name of this employee from Mary to Sarah. So let's use update one method for that. The first parameter to this method is the filter, which we use to find the employee that we want to update. We want to find the employee whose name is Mary. So the field is name, and the value for this is Mary. And the second parameter contains the updates. So we want to change the name of the employee from Mary to Sarah. So we specify that as the second parameter. $set. What do we want to set? We want to set the name of the student to Sarah. So we use another pair of curly braces. The field is name and the value is Sarah. What if we want to change multiple fields? Well, simply separate them with a comma. So along with the name, let's also change age. So we again include double quotes. The field name is age, and let's change it to 100. And let's not forget to use colon after $set. Notice both matched count and modified count is 1, which means MongoDB found one document and updated that one document. Notice the second document in the result set, name is changed to Sarah and age to 100. Now let's try update many. So instead of update one method, we want to use update many. And let's find all the documents where gender is female and change the gender to unknown. So instead of name, the field is gender and we want to change it to unknown. we only want to update one field, so let's delete the age field. There we go. Both matched count and modified count is 2. Notice the second and third documents, gender is unknown as expected. So you might have already guessed the pattern. To delete a single document from the collection, use delete one. And to delete more than one document, it's delete many. Now, let's delete this document where name is Sarah. So instead of update many, we want to use delete one method because we want to delete one document. And with delete one method, we just need to specify the document that we want to delete. We want to delete the document where the name field value is Sarah. Let's delete the second parameter. There we go. Deleted count is 1. This means in our collection, we should only have 3 documents. Notice Sarah's document is gone. Now, let's try delete many. So here's what we want to do. We want to delete all the documents where age is less than 31. Notice these first 2 documents, age is 29 and age is 30. So we want to delete these 2 documents and retain only this document where age is 31. So let's use delete many for that. So instead of delete one, we want to use delete many, and we want to delete all the documents where age field value is less than 31. So we're going to use comparison operator. So we want another pair of curly braces. The operator that we want to use is LT for less than, and the value that we want to compare is 31. There we go. Deleted count is 2. This means in our collection, we should have only one document. There we go. So far, we have been using MongoDB shell to perform CRUD operations. Now, let's do the same using MongoDB Compass, which is a GUI, that is a graphical user interface for querying, visualizing, and modifying database data. Behind the scenes, both the shell and Compass issues the same commands to the database server. Navigate to mongodb.com, and if you have not already signed in, click on the sign in button, provide your login details, and sign in. I've already signed in. After you sign in, make sure you're on the databases tab and then click the connect button. We want to connect to MongoDB using MongoDB Compass. So click on this last option here. Now, if you do not already have MongoDB Compass installed, click on this button, select your operating system from the drop-down list, and then download the software. Follow the on-screen instructions to install it. After you have MongoDB Compass installed, click on this button, I have MongoDB Compass, and then select the version that you have from the drop-down list and copy the connection string from here by clicking this button. And then in the start menu, search for MongoDB Compass. You'll land on this new connection page. If you don't see this new connection page, you can always click on connect and then select this option, new connection. In the text box here, paste the connection string that you have copied, and then we need to provide the value for password field right here. We need to remove the angle brackets as well, or click on this link right here, fill in connection fields individually, where we can see host name, authentication method use, username, and then we can provide our password. And then click connect button. There we go. We are now connected, and at the moment we have 3 databases: admin, local, and my first database. If you want to create a new database, click on this button, create database, and then follow the simple on-screen instructions. If you want to delete any of these databases, click the delete icon next to the respective database. At the moment, we only have 3 databases, but then if you have a lot of databases and collections, you can search for a specific database or a collection using the search interface right here. Notice as soon as I type STU, we can find student courses collection in my first database. So we want to write a few queries against my first database. So let me click on the database name right here. We have 2 collections in this database, student courses and users collection. Let's click on student courses. Notice at the top of the page, we have our database name dot collection name. And at the moment within this student courses collection, we have 2 documents and 1 index. We can see those 2 documents right here. And when I click this button, both the arrays and objects within the current document are expanded. And we have 3 views here. at the moment this first icon is clicked. When I click on the second icon, we have a different view. And if you prefer tabular view, click on this third icon. And to add data, click on this add data button, and we have two options here. We can either import data from a JSON file or insert a document manually. So let me select this second option. There are two ways to insert a new document into a MongoDB collection. We can paste our JSON document right here, or using this view, we can enter individual fields. Let's try pasting the JSON document. Click insert. There we go. We have our new document inserted into the collection. Notice we did not provide a value for the ID field explicitly, but MongoDB has provided a value for it automatically as it is a required field. Now let's try providing values for individual fields. Same idea, click on add data, insert document. We want to enter fields individually, so I'm going to click on this. We already have a value for the required ID field. Now we want to add a new field to this document. So I'm going to click on this plus sign, add field after ID. The name of the field is name. And then I'm going to press the tab key, provide a value for this field. I'm going to call the employee Pam. Age 29. We want to change the age data type to number. By default, MongoDB assigns string, but we know it's an integer. So I'm going to click on this drop-down list and select int 32. Next, gender, female. Press the tab key again, and we want to enter next field, graduated, and this is going to be false, and it's a Boolean data type. So let's change it by selecting it from the drop-down list right here. And next, we want to enter address, which is an object. So change the data type to object from the drop-down list right here. Address is an embedded JSON document with its own set of fields and values. Within this address nested JSON document, we want two fields, street, which is of type string, and the value is 123 King Street, and city. Let's call the city Mongo City. And finally, we want to add an array, the list of courses. Notice when I pressed the tab key, it provided me the option to add a third field into this nested address JSON document. And I don't want to do that. If you want to delete anything at any point, you can click this icon right here. And that removes that. We have the other field here. So I want to add here courses. And this is going to be of type array. So from the drop-down list, I select array. And then we have the option to enter our first field of the array. C++ is the first course, Java, and finally .NET Core. And then to insert this document into the collection, simply click Insert. There we go. We have our fourth document inserted into the collection. And notice the message that we have at the top here, displaying documents 1 to 4 of 4. We can use this text box here to find the documents. Notice when I simply type a pair of curly braces and then click this find button, notice we see all the 4 documents that we have in the collection at the moment. To filter documents, we can specify our filter criteria within the pair of curly braces right here. For example, let's say we want to find all documents where name field value is Venkat. By the way, notice at the moment filter is red and the find button is also disabled. This is an indication we have a syntax error. So the value for name field is Venkat. Notice now we can click on the find button and we get that one matching record, Venkat. Now, let's make this filter expression a bit more complex. For example, let's say we want to find all documents where name is Venkat and age must be greater than or equal to 29. So we want to specify another filter expression here. So I'm going to include a comma and then a pair of curly braces. The field is age, so age colon, and we want to specify the age must be greater than or equal to 29. So we're going to use the comparison operator GTE. And to use the comparison operator, we're going to use another pair of curly braces. The operator is GTE. Notice we also have IntelliSense colon, the value is 29. Now we want to apply AND operator between these two filter expressions. So I'm going to wrap both the filters within a pair of curly braces, and the operator that we want to use is and. So dollar and, again we have IntelliSense, colon, and then wrap this entire expression in another pair of curly braces, and then click Find button. We only have one such a document where name is Venkat and age is 29. Now to change it to or, simply replace and with or operator. Click Find again. Notice we have 4 documents satisfying this filter criteria. Either the student name is Venkat or age is greater than or equal to 29. Now let's change age of this student Ben to 25. So we want to edit this document, and in MongoDB Compass, to do this we simply click this icon right here which says edit document. So this document right now is in edit mode. Now let's change age from 31 to 25. Notice we see the message here, document modified, and to update this document, naturally we have to click this update button. There we go, document updated, age field value is 25. Now let's click this find button again. Notice now we only have 3 documents satisfying this filter criteria. And when I click on the options here, we can also specify a projection, that is the fields we want in the result set. By default, all the fields are returned. Let's say, for example, we only want name and age fields. So name :1, comma, age :1. By default, remember, ID field is always returned. If you don't want it, you have to explicitly specify that. So _ID :0. And we can also specify by which field we want the data to be sorted. We want the data to be sorted by age field. To sort in descending order, use -1, in ascending order, 1. And then we can also specify the number of documents to skip and limit. Click the Find button. Notice in the result set, we now have only name and age fields, and the data is sorted by the age field in ascending order. To reset the filter, click this button, Reset. Notice the filters are cleared and we see all the 4 documents. In MongoDB Compass, to delete a document, simply click the delete icon next to the respective document. This specific document is now marked for deletion, and upon clicking the delete button again, the record is gone. Hey guys, I am Venkat, and this is part 3 of MongoDB video series. In this video, we'll discuss building a RESTful API service using Visual Studio 2022, ASP.NET 6, and MongoDB database. Visual Studio 2022 is the latest IDE from Microsoft. If you don't have it installed already on your machine, navigate to this website, visualstudio.microsoft.com/downloads, and then select this first option, download Visual Studio with .NET. The Community Edition is free and will do for the API that we are building in this video. So select this first option, download the Community Edition, and then follow the simple on-screen instructions to install Visual Studio 2022. After the software is installed, fire up Visual Studio, click on File, New, Project. We want to create an ASP.NET Core Web API. So using the search text box here, search for ASP.NET Core Web API. We have a couple of matches here. The first one is for C# and the second one is for F#. We want to use C#, so let me select that and then click Next. Let's name our project Student Management, and I'm going to create at this location C:projects, and the solution name is also Student Management. Click Next. As of this recording, the latest .NET framework is .NET 6. So select it from this drop-down list as the framework. Leave authentication type as none, and then check these 3 checkboxes: configure for HTTPS, use controllers, and enable OpenAPI support. We discussed what is Swagger and OpenAPI specification in detail in parts 29 and 30 of this Azure video series. So if you're new to these 2 concepts, please check out these 2 videos. So on this additional information screen with .NET 6 selected and these 3 checkboxes checked, click Create. There we go. We have our project created. The first thing that we want to do is install MongoDB.driver NuGet package. So let's go to Solution Explorer, right click on the project name, and then select this option, Manage NuGet Packages. Make sure you are on the Browse tab, and then in the search text box here, search for MongoDB.driver. Notice the first option here is the official .NET driver for MongoDB. Select that and then click Install. Accept the license agreement. There we go. NuGet package installation complete. Now what we're building here is a student management API, and we're going to store all our model classes in a separate models folder in our project. So let's go to Solution Explorer, right click on the project name, and then we want to add a new folder. Let's name it models. And in this models folder, let's add a new class. Let's name it student. Now, when data is retrieved from MongoDB database, the student JSON data is mapped to this student class in .NET and vice versa. So within this student class, we need a few properties. First, let me paste those properties here. From the MongoDB.driver NuGet package that we just installed, we need two namespaces. So at the top of this student.cs file here, let's include those two using declarations. So we need MongoDB.bson namespace, and we also need MongoDB.bson.serialization.attributes. We want this ID property in this student class to be mapped to this ID field in the student JSON document in MongoDB. To achieve this, we're going to decorate this property with BSON ID attribute. Notice when I have the mouse over from the IntelliSense, we can see this attribute is coming from MongoDB.bson.serialization.attributes namespace. And this is the reason we included this using declaration. I'm going to decorate this ID property with another attribute, BSON representation. This attribute automatically converts Mongo data type to a .NET data type and vice versa. In this specific example, it's going to convert Mongo data type object ID to a .NET data type string and vice versa. Notice this Boolean is graduated property. I'm going to decorate this property with BSON element attribute. Basically, it's mapping this Boolean is graduated property in our student class to graduated field in the Mongo document. Let's do the same with these other properties as well: name, courses, gender, and age. There we go. The rest of the properties are decorated with BSON element attribute. At this point, you might be wondering, all these properties, especially name, courses, gender, and age, have the same name as the fields in Mongo document. So what's the need to decorate these properties with BSON element attribute? Well, the casing is different. That's the reason. In C#, the properties start with an uppercase letter, whereas in Mongo, the fields start with lowercase. There are several approaches to handle this case-sensitive mapping. One of the easiest and clean approach is to use BSON element attribute. Now, if we take a look at one of the student documents in Mongo database, notice we have address field in the document. But if we take a look at the student class on the .NET side, we don't have a property corresponding to the address field. So the question is, what to do if we receive extra fields from Mongo database? Well, we can instruct the serializer to ignore any extra fields. And the way to do that is by decorating this student class with BSON ignore elements attribute. Next, in our application configuration file, that is in appsettings.json, we're going to include Mongo database connection string and other pieces of configuration data that we need. Now, if we take a look at MongoDB Compass, notice the collection name is student courses and the database name is my first database. And this is the configuration data that we are storing in our appsettings.json file. The collection name is student courses and the database name is my first database. All that is left to do is to get the connection string. To get the connection string, log into your MongoDB Atlas account and then make sure you are on the databases tab, click connect. We want to connect our application. So select this second option. And from the drop-down list here, select your programming language. In our case, we are using C# and .NET. We also need to select a version. The version that we are using is later than 2.13. and copy the connection string from here. Paste it within our app settings.json file right here. Next, replace the password, including the angle brackets, with your actual password. And if we take a look at our MongoDB Atlas account, notice the message here: ensure any option parameters are URL encoded. To URL encode your password, navigate to this website, urlencoder.org, type in your password. I have it typed as hola hola space 123, and then click this encode button. And we have the encoded password right here. Let me copy this and paste it in app settings.json file. Next, in the models folder, I'm going to include a new interface. We'll understand the purpose of this new interface in just a bit. I'm going to name this interface iStudentStore Database Settings. Inside this interface, I'm going to include three properties. Notice the names of these three properties. They correspond to the three settings that we have in our app settings.json file. Next, again, in the models folder, I'm going to add a new class file. Name it Student Store Database Settings. Now, we want this class to implement this interface, iStudentStore Database Settings. And then we obviously want to provide implementation for these three properties. If you're wondering, why do we need this class and interface? Well, we're going to use these two to read and store Mongo database settings that we have in our app settings.json file. We'll discuss how to do that in just a bit. Now, for separation of concerns, we're going to place the code that calls Mongo database in a separate service layer. So to our project, let's add services folder. So right click on the project name in Solution Explorer, add new folder. Name it services. In this folder, let's add a new interface. Name it iStudentService. Click add. We want this service to be able to perform all CRUD operations. So let's include the required methods. Bring in models namespace. This first method get returns the list of all students. This method returns a single student by ID. Create creates a new student and returns that newly created student. Update updates student by ID. And finally, this remove method deletes student by ID. Our obvious next step is to provide implementation for the service. So in our services folder, let's add a new class file. Name it student service. We want this class to implement the interface iStudentService. Press Ctrl period and select the first option, implement interface. We want to inject a couple of things into this service. So let's include a constructor for that. Now, our Mongo database settings are present in this file, appsettings.json, and we need these settings in our student service. And we also know it is this interface, iStudentStore database settings, that is going to carry these settings from appsettings.json file to our student service. In a bit, we'll discuss how this interface is going to read the database settings that we have in appsettings.json file. For now, let's inject the interface iStudentStore database settings into our student service, and let's call this parameter settings. We also need iMongo client interface, and this interface is present in this NuGet package, mongodb.driver. So let's include the required using declaration first, mongodb.driver, and we want to inject iMongo client. Let's call the parameter Mongo client. On this injected Mongo client interface, we have get database method. Obviously, this is going to return the database for us, and for it to be able to do that, we need to specify the database name, and it is the settings object that carries the database configuration information, including the database name. Notice on the settings object, we have database name property. Let's store the database in a variable called database. On this database instance, we have get collection method, and as you can see from the IntelliSense, it supports generics, using which we can specify the type of collection. In our case, the type of collection is student, and obviously for this method to be able to retrieve the collection, we need to pass it the name of the collection. Again, this incoming settings object has got the collection name, so settings dot student courses collection name, and let's store this collection in a variable called students. We don't have this field yet, so when I click on the field and then press Control period, we have different options here. Select the second option, create read-only field. Our obvious next step is to provide the implementation for all these CRUD methods that we have in this student service. Let's start with create. We want to insert this incoming student object into our collection underscore students. So underscore students, this is our collection, and on it we have insert one method. Because we are inserting one student, we're going to use this method, and obviously the parameter for this method is the incoming student object. And then let's return the inserted student object. Next, get. We want this method to return the list of all students. So again, on our students collection, we have find method, and we want this method to return the list of all students. So the lambda that we are going to specify here always returns true. So we get the list of all the students. Finally, convert this to a list. And we want to return it. So let's include the return keyword. Next, we want to get a single student, that is student by ID. It's going to be very similar to the implementation of this get. So let's make a copy of it. So we want to find a student where student ID equals incoming ID. And we are getting a single student here. So instead of toList, we will use first or default. Next, remove. We want to delete a student whose ID matches with this incoming ID. Again, the implementation is going to be similar. So let's make a copy of this statement. This method is not returning anything, so we don't need the return keyword. And instead of find method on the students collection, we want to use delete one method, because we are deleting one student. So delete the student whose ID matches with the incoming ID. Finally, update. This method has two parameters, the ID of the student whose details we want to update, and the student parameter contains the updated values. Again, the implementation is going to be similar to remove. So let's make a copy. And instead of using delete one, we want to use replace one method. So the first parameter is our filter expression, which we use to find the student whose details we want to update. In our case, we want to find the student whose ID matches with this incoming ID. So that's our first parameter. And the second parameter is the replacement. And this is the student object that contains our updated values. Now, here's the important bit to understand. Into this student service, using this constructor, we are injecting these two dependencies, iStudentStore database settings and iMongoClient. And notice both are interfaces here. So we need to tell ASP.NET Core dependency injection system what concrete implementations to provide for these two interfaces. And we do that in program.cs file. This is standard dependency injection in ASP.NET. If you're new to dependency injection, we discussed it in detail in part 19 of ASP.NET Core tutorial. So please check out this video. So in the interest of time, let me paste 4 lines of code here and then I'll walk you through it. First, let's fix all the compilation errors by including the required using declarations. So this line number 10 here is basically telling ASP.NET to get the section with the name StudentStore database settings from appsettings.json file. So basically, if we take a look at appsettings.json, notice we have a section with that same name, StudentStore database settings. So basically, it's telling get all these settings from this section and then map them to this class StudentStore database settings. And then this line right here is tying the interface iStudentStore database settings with StudentStore database settings class, meaning whenever an instance of this interface is required, provide an instance of StudentStore database settings class. And if you remember, within our student service class, we are injecting iStudentStore database settings interface. So whenever this interface is required, provide an instance of StudentStore database settings class, which contains the configuration information that we have in appsettings.json file. And then here we are specifying to MongoClient the database connection string. Now, again, in our student service, we're using this injected iMongo client to get the database. And for this service to be able to get the database, it needs to know the database name. So basically, we need to specify where it has to read the database connection string from. And here we are specifying that configuration information. And finally, we are tying our iStudent service itself with its implementation. So here we have our student service, which implements iStudent service. Our final step is to include a controller that exposes all these CRUD methods that we have in this student service. So to the controllers folder, let's add a new controller. What we actually want to add is an API controller and not an MVC controller. So select API and then select API controller with read-write actions. Click Add. Provide a name for the controller. Let's call our controller Students Controller and then click Add. There we go. Students Controller is added with all the required plumbing in place. Notice this class is decorated with these two attributes: API controller, which makes it an API controller, and then the route attribute. So with this attribute in place, when we navigate to /API/ the name of the controller in the browser, in this case, the name of the controller is students. So when we navigate to API/students, this is the controller that is hit. And the first thing that we want to do inside this controller is inject this student service into it. And to be able to do that, we need a constructor. So let's include it. And the service that we want to inject is iStudentService. Let's bring in the required namespace first. And let's name the parameter student service. Generate the required private field by pressing Ctrl and then select the second option. When this get method is called, we want to return the list of all students. For that, we're going to use this injected student service. Remember, on our student service, we have get method. So if we go to student service, notice we have the get method here, which is returning us a list of student objects. So within our students controller, let's change the return type of this method to action result of list of student objects. Let's bring in the required namespace. Next, we want to get student by ID. So in the URL, when we navigate to API/students/the ID of the student, then we want this method to return that specific student whose ID value matches with the ID we have in the URL. And that ID value is passed to this method. Now, if we take a look at our student class, notice the ID property value is string. So first, within our controller action, let's change the data type to string. As you can see, the implementation is pretty straightforward. We pass this incoming ID parameter to the get method on our student service. This is the service which actually looks in the MongoDB database with the student with that respective ID. If student is null, that means we have not found the student. So we return this message, student with ID equals whatever is the ID not found. Otherwise, we return that student. So the return type of our get method is action result of student. This post method creates a new student object. The new student details will be passed into this method from the body of the request. Hence, this parameter is decorated with from body attribute. And what we'll get into this method is a student object. So let's change the data type here to student, and let's also call the parameter student. Implementation is a two-liner. As you can see, we are passing the student object to the create method in student service, which will actually create an entry for this new student in the underlying MongoDB database. And then we're using this created at action method. Notice from the IntelliSense, this method returns the HTTP status code 201 created. And this method also sets the location header, using which we can access the newly created student object. And for that, we are making use of the get action within this controller. And if we take a look at this get method, notice for it to be able to return the student that we have created, it needs the ID of that student, which we are passing using this second parameter right here. And the third parameter is the newly created student object itself. And from the IntelliSense, notice the return type of this method is created at action result, which again implements action result. So let's change the return type to action result of student. Next, put, which we use to update existing student details. The student ID is of type string, and this parameter is going to be the student object itself, which contains the updated values. So the type is student, and let's call the parameter also student. We pass this incoming ID parameter to the get method in our student service and retrieve the existing student. If existing student is null, that means we have not found the student with the given ID. So we return the message saying student with the ID equals whatever is the ID not found. Otherwise, we pass both the parameters, the student ID and the student object that contains the updated values to the update method in our student service, which will actually update the student record in MongoDB database. And then finally return no content from this method, HTTP status code 204. And notice from the IntelliSense, the return type of this method is no content result, which means we can again use action result as the return type. Finally, delete. First, let's change the data type of ID to string. We pass the incoming student ID to the get method on our student service, which will retrieve the existing student. If existing student is null, that means we have not found a student with the provided ID, so we return not found. Otherwise, we pass the student ID to the remove method on our student service, which will remove the respective student record from MongoDB. And then finally return this message, student with ID equals whatever is the ID deleted. And if you notice, the return type of this method is OK object result, which means we can also change the return type of this method to action result. With all these changes in place, let's run our project. There we go. Our API is up and running. And here we see all our students controller actions. If we issue a GET request to this endpoint /API/students, we get the list of all students. And to try out this action, click this button, try out, and then click execute. Notice the server response, we have the status code 200 OK, and in the response body, we have an array of student objects. If we take a look at MongoDB Compass, at the moment in the database, we have 4 students, and we see those 4 students in the response body right here in an array. Next, let's try post. We use a post request to create a new resource. In our example, if we issue a post request to this endpoint /API/students, a new entry for the student will be created in MongoDB. So let's try it out. In the request body, we need to include the student object that we want to create. Let me paste a student object that I already have. ID property is not required. A value for this field will be automatically provided by MongoDB. So let me delete that. And as you can see, the name of the student here is Sarah. We also have the rest of the fields populated. So let's click execute. There we go. The HTTP status code is 201 created, and in the response body, we have the newly created student object, including the ID field value that is generated by MongoDB. If we take a look at MongoDB Compass, notice we have that newly created student right here. Notice under response headers, we have location URI, which we can use to access this newly created student object. So let's copy this location URI, paste it in the browser, and we have that newly created student. Next, let's try get student by ID. So if we issue a request to this URI, API/students/ the ID of the student, we get that specific student. So let's try it out. In the ID field, we need to provide a value for ID. So let's get this ID from the browser. Execute. There we go, status code 200 OK, and in the response body, we have that specific student. Next, let's try put. We use put to update a resource. In our case, let's update Sarah's record. Let's change name to Sarah1 and update few other fields. There we go. In the server response, we have the status code 204 no content. And if we take a look at MongoDB Compass, notice Sarah's record is updated as expected. Finally, let's try delete. And to be able to delete a resource, we need to specify the ID of the resource. There we go. Status code is 200 OK. And if we take a look at MongoDB, notice Sarah's record is gone. That's it in this video. Thank you for listening.